Hi class, this is Mr. Morris. Today we're talking about net ionic equations. Take some notes on this real quick. A net ionic equation is basically a shortening of a double replacement reaction. So we're going to be doing a lot of double replacement reactions that are actually precipitation reactions. I don't know if you remember that word, but a precipitation reaction is something that forms a solid. So let's get started by just kind of explaining the notes. We'll do some examples, and then hopefully you'll have some time to do some practice. First of all, a net ionic equation shows only the species actually involved in the reaction. In other words, what it's actually showing is the formation of a solid precipitate. We're only showing the ions involved in forming a solid precipitate. The steps that we take, there's 3 steps really. The first step is to write the complete balanced equation. Okay, it gives the overall reaction stoichiometry, but not forms of the reactants and products that actually exist in solution. The key here, this is the way you learn to write a chemical reaction. Okay, so it's just writing the chemical equation the way that we predicted products. It's the overall reaction, the way you know how to write it right now. A good tip and something I want you to do, especially preparing for the quizzes, I want to see this, is to underline the solid precipitate to help you with the later steps. So you're going to write the balanced equation and you're going to underline the thing that's solid. Okay? We're going to use the solubility rules to figure that out. The second step is to write the complete ionic equation. The complete ionic equation represents it as ions, all of the reactants and products that are soluble and ionized in the solution. So if you remember, we talked about our solubility rules before. Here's a copy of the solubility rules. So we've talked about this before. And if it's soluble, that means it's aqueous. If it's insoluble, it's solid. Again, insoluble is solid. Soluble means aqueous. So as we're going through this, we're going to be referring back to these very often. You just want to keep in mind, if it's soluble, it's aqueous. The exceptions up here would be insoluble. They're solid. And down here, if it's insoluble, that's solid, and the exceptions would be soluble or aqueous. So we're going to come back to that several times. Referring to the solubility rules, which is that's what you're going to do every time. That's why you get to use those on the test. You're going to refer to the solubility rules. Remember that aqueous, we say AQ or aqueous, that is soluble. So it will dissociate. Or in other words, it's going to split into ions. If it's solid, it's insoluble. So it will stay together. It's not going to split. It's going to stay held together as a compound. It's solid. Okay, our net ionic equation is the last step. So we do the complete balanced equation, just the way you're used to doing an equation, and then balance it. The complete ionic equation, where you take that balanced equation and split apart the ones that are soluble. And then we have the net ionic equation. That's the one that only includes the solution components undergoing a change. Cancel out all ions that are apart, that are not part. So we're going to cancel out everything that is not part of the reaction process. In other words, we're canceling out ions not involved in forming the solid precipitate. Ions that are not involved in forming the solid precipitate. Okay. The ions that cancel out are called spectator ions. That is a vocab term that I want you to be familiar with. The spectator ions are the ones that we're going to cross out. So let's get started. Our first example right here. Write the net ionic equation for the following reactions. Step 1, complete balanced reaction. That's just writing this, predicting the products like we have in the past. So barium chloride is, barium has a +2 charge, chloride has a -1 charge. Silver is +1, nitrate is -1. And you can look this up on your periodic table. Take a little more time if you need to go back over the examples. Barium is +2 and chloride is -1. So that means I need to have 2 chloride, BaCl2. Plus silver nitrate, that's Ag, and the nitrate is NO3. +1 -1 is already canceled out, so I'm just going to write my arrow. All right, when they switch, barium is going to pair up with nitrate. So we're going to have Ba, with our +2 charge, and NO3 has a -1. If I have a +2 and a -1, I need to have 2 of these. And then the other one is going to be Ag and Cl, which are both +1, -1. So that's going to be just AgCl. Okay, let's go ahead and balance this. Put some lines here to balance it. All right, BaCl2. Ba is balanced, but Cl is not, so I'm going to put a 2 right here. All right. Ag. Okay, there's a 2 there. I'm going to put a 2 here. 2 Ag, 2 NO3. It's all balanced now, so 1, 1. All right, next thing we need to do is consult our solubility rules. If I look at my solubility rules, the first thing I see is BaCl2. So let's find Ba is not an alkali metal. Cl, okay, they're soluble unless AgPbHg. Okay, sounds like this one is soluble, so I'm going to put AQ. Remember, you put AQ every time they're soluble. AgNO3. Okay, anytime there's an NO3, it's going to be soluble, no matter what. So I'm going to put AQ. Since that's a rule with no exceptions, I'm going to find out where the NO3 is over here, and I'm going to put AQ by that. Okay, we could guess that this is the one that's going to be solid, but let's check. Ag is not an alkali metal, and Cl, let's see, Cl is usually soluble, but not if it's with Ag. Okay, AgCl, this must be insoluble, so it's solid. Okay, now we want to do step 2. Step 2 is the complete ionic equation. We've got a balanced equation. Now I just want to split it apart into ions. So barium is a +2 charge. I'm going to put 1 Ba +2 plus how many chlorine? Got 2 Cl -1 plus, okay, now I've got 2 Ag. And you've got to write the charges or it's not ionic. You have to have an ionic equation. Net ionic means we need to see those charges. 2 Ag, Ag has a +1 charge. Okay. Plus nitrate, we're going to write NO3, which is nitrate, -1 charge. Go to the other side. I've got Ba, and it doesn't matter if you write the 1 here or not. If it's a 1, you can leave it off. Ba +1. Oh, and I forgot, we should underline that. We're underlining our solid because we need to keep that together. 1 Ba, oh, Ba is actually +2, I'm sorry. Ba +2 plus 2 NO3 -1 plus 2, this one doesn't split, it's solid. 2 AgCl as a solid. I'm going to underline it again to remind myself in the next step. Okay, I'm going to switch pen color. You don't have to do this. But the last step is to cancel out the spectator ions. So we're going to cancel out anything that is not part of the reaction process. All right, the reaction is actually the formation of AgCl. That's my precipitate. So the other ions that are not involved in changing, they look the same on both sides. So NO3, can cross that out, 2NO3 minus 1, because on the other side I have, and I wrote this incorrectly, because that 2 multiplies here, 2NO3, okay. 2NO3 minus 1, this is 2NO3 minus 1, it cancels out. I have 1 Va plus 2, cross that out, and then go over here, Va plus 2. All right, that is a really important step, because now I just copy down everything I didn't cross out. 2Cl minus 1 plus 2Ag plus 1 yields 2AgCl as a solid. And you should have a balanced reaction at this point. 2 chlorine, 2 silver, that's it. This is my net ionic equation. On a quiz or test, you will be required to have all 3 steps written out to get full credit. But that's the end result that we're looking for.